So let's focus in on some part of this visualization. I want to look at movies produced since the year 2000. So what I want to do is I want to select all of the movies in my data set that were released after the year 2000. But I also want to focus in, I want to look at movies produced on the year 2012 or before. So I want to select also all of the movies that were less than 2013. So I want to select between 2000 and 2013. And we don't really know how to do that yet. We know how to select movies released since 2000 and movies released before 2013, but not both at the same time. All right, so here's how we would select since the year 2000. So I'm going to get the index, I'm going to compare it to 2000, and I get trues where the movie year, the release year of the movie, or sorry, the year I'm talking about was 2000 or later. So if I look back at the index, remember this is what I had. So 2015, 2014, all of these are greater than 2000, and so I see true. I can do the same for before 2013. I get a bunch of falses, and then I get trues where I'm before 2013. What I want to do is I want to combine these two Boolean series, or Boolean arrays, and get an array which is true for every entry which is after 2000 and before 2013. Now, to do that, basically I want to say and. I want to use the word and. Am I after 2000 and before 2013? Here's how we do that in Python. I write my first condition after 2000. I write and with an ampersand, and then I say less than 2013, before 2013. Okay, and I put both of these conditions here in parentheses. That's very important, as we'll see in a second. So I say movies released after years after 2000, years before 2013, and put and in the middle. I run this, and I get an array which is true in every entry, which is true in exactly both. So you see, for example, this one's false because this one's true, but this one's false. So they're not both true. This is true because this one is true and this one is true. So this is true. And here this is false because this one's true, but this one's false. So I can then use this series, this new Boolean array, to index or to query my data frame and select only the rows corresponding to years after 2000 and before 2013. So here's what it looks like. So I throw that into the square brackets. I get back all of the rows corresponding to years after 2000 and before 2013. Now, just a quick note here about the sort of syntax of what's going on. I've just sort of indented things to make it easier to read, and this is how I personally like to indent multiple selections like this. If you have the square bracket here and the square bracket here, Python understands that you are continuing the code whenever you make a line break. So this ampersand operator, it's our way of saying and when working with Boolean arrays. So what it does is it takes two Boolean arrays of the same size and returns a new Boolean array in which an element is true only if the corresponding elements in both input arrays are true. Now, the parentheses are important, as I said. If you forget the parentheses, the code will still run, but it will not give you the right answer. So let's see this. So I want to select years before 1995 in which more than 500 movies were released. So break this into two, where I say X and Y. X is years before 1995. Y is more than 500 movies released. I want to put and between those two things. So how do I get years before 1995? I say movies by year. Remember, the years are in the index. So I say before 1995, and that's how I say that. I'm going to put parentheses around it right off the bat so I don't forget. And then I'll say, and I want rows in which more than 500 movies were released. So I'll say movies by year dot get, and then I forget the column name. It was like number of movies. Let's check. Yeah, number of movies, okay. Okay, and I put that in parentheses. You notice that Jupyter tries to be helpful and auto completes my parentheses for me. Now I'm still leaving out a little bit of code here. I want to select where more than 500 movies were released, so I say greater than 500. Run this cell and I get a Boolean array back. And this consists of an array where every entry is false if this is not satisfied, and true exactly where I have a year before 1995 and 500 movies were released. Now let's try this again, but without those parentheses, and see what we get. Okay. You see it's not going to run here. Sometimes you can get a situation where it actually runs, which is kind of sneaky, depending on exactly what code is written here. And it'll run, yet give you the wrong answer. So make sure that you put your parentheses around the conditions. Now this is just two conditions, but I could add a third condition by putting another and here, and then writing the code there for that condition. So for example, years before 1995, in which more than 500 movies were released, but fewer than 700, I would write and movies by year dot get number of movies less than 700. Okay. So now I'm going to take that Boolean array that I just created. I'm going to pass it into the table, movies by year. So that's what I'm doing here. I'm selecting only those rows, and then I'm going to plot. I'm going to make a line plot of the number of movies, just using the x-axis from after 2000 and before 2013. So here's what we see. So we said before that the number of movies seems to be increasing since the year 2000, but in the year 2009, we had a major dip in the number of movies released. So the question is, what happened in the year 2009 and 2010? Whenever you're plotting like this, if you see something sort of strange, it's good to stop and think, why? What's going on here? Well, of course, in the year 2000, in the year 2009, 2010, we had a major crash in the stock market. The Great Recession occurred, and so it's not surprising to see the total number of movies decreased. But we can also look at the total gross. How much money did these movies make? You know, the total number of movies released decreased, but did people stop going to the movies? Okay, so we can answer this question by selecting the same rows from our table and plotting, instead of the number of movies, the total gross. And here's what we see. There is no dip in the year 2009 and 2010, which is kind of interesting. The explanation is that during a recession or even a depression, people tend to still go to the movies to kind of get their minds off of things. They forego more expensive luxuries like, I don't know, buying a new car that year, but they'll still go to the movies to kind of get some source of entertainment, even though times are not great. So here's a bit of trivia. What was the top movie of the year 2009? So you can get the answer by getting the movie column and then .loc, the label, 2009. So what's your guess? What was the top movie of 2009? Let's see. Avatar. What was the top grossing movie of 1989? Take a guess on this, and then we'll see the answer here. All right, so I'm just selecting, don't worry about this code too much, we'll see how to do this in a future lecture, but I'm just selecting all of the rows that were a possible answer. So the top grossing movie of 1989 was Batman. I like asking this question in lecture because a lot of people are like, oh, it was Toy Story or something like this, and man, that was released 6 years after 1989. Okay, let's take a look at bar charts.